Our next topic is called simplifying radicals. Okay, now to start, what we need is the collection of perfect squares. Oops. Now, a couple of days ago when you worked on the first worksheet for this chapter, you actually made a list of all the perfect squares. They are what 1 squared is, what 2 squared is, what 3 squared is, what 4 squared is, and so on. So the perfect squares are 1, 4, 9, 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and they keep going, but I think those are the ones we're going to need. This list is really important, and you are going to need to look back on this list over and over and over again, unless you memorize this list of numbers, to be able to do the problems that I'm about to show you. Now this part you don't need to write down, but what I do want to tell you is that a long time ago when you learned about fractions for the first time, and your teacher probably told you something like this: it is not proper to leave a fraction looking like the way the one I wrote on the board or in right here is, because since both numbers are divisible by 5 and you can reduce the fraction, then you should. And you would present the fraction not as 15/20ths, but as 3/4. And you learned that, I don't know, back when, and so you're kind of used to that. Well, there is a way that we are going to simplify or reduce numbers inside radicals, and I want to tell you what a radical is to start with. A radical is just a number in a square root. The square root itself is called a radical, and you could actually say this number a radical 8 instead of the square root of 8. And right now the square root of 8 is not proper. People that know math know that the square root of 8 is not the proper way to write this. Here's why. One of the perfect squares divides evenly into 8, and if any of them do, you must kind of adjust things. So I think you'll agree that 4 is the number on your list that divides evenly into 8, and 8 is 4 times 2. Now, what we're going to do next, let me stay with red, is it is a rule in math that if you have two things multiplied under a radical, that you can give each their own little house, their own little radical. And then it turns out that the square root of 4, if you took that on your calculator, is just this cute little 2. But the square root of 2, although 2 is very nice, when you take the square root of it, you get a decimal. And so that is kind of yucky, and so we are just going to leave that like this. Now, if you were to take your calculator and take the square root of 8, you would get a decimal. And if you took 2 times the square root of 2, you would get the same thing. These are the same thing, but this is considered more proper. It is considered simplified, just like when we reduce the fraction. Okay, I'm going to change pages so I don't run out of room with the next example. I'm sure you really don't need to. Here's the next one. Okay, the next one we are going to simplify is the square root of 150. So, when you switch pages, you may want to do this. I'm going to do this really quick. I'm going to write a list of all the perfect squares up here, or as many as I can fit in one row. Hopefully there are enough of them to... Okay, I think I got them all. Yes. All right, so the first thing you're going to do is say, which of these perfect squares is the biggest one that will divide into 150? And because I'm still showing you, I'm not going to make you stop the screen or anything. I'll just show you. The square root of 150 is divisible by 25. 25 is from our list. And 150 is 25 times 6. So what you can do is say 25 gets its own radical, 6 gets its own radical. The square root of 25, because it's on the list, has just a super cute little answer, 5. And the square root of 6 isn't on the list, and when you check, its square root is a decimal. So you are just going to leave it like this. 5 times the square root of 6, or 5 radical 6, is a simplified version of the square root of 150. Now, I'm going to have you try the next one yourself, because you've seen 2. The next one is the square root of 54. Even if you're unsure, I want you to try this one before you watch me do the problem. So stop now and try this one. Here's what I hope you did. The square root of 54 is the same thing as 9 from our list times 6. 6 is not on our list. The square root of 9 is 3. And the square root of 6, which is not on our list, is a decimal, so we're just going to leave it like this. Now you can start to skip that step in between. You can take the number from our list and say, for it to get out of the radical, you have to take the square root of it, and that's where we get 3 from. And 6, which is not on our list, has to just stay inside the radical. So you can skip that in between step, which I'm going to start to do now more often. Let's try another one. The next one is the square root of 200. Stop the video and please try this one. Here's what I think you did. The biggest perfect square that divides in there, now 4 totally divides into, it's 4 times 50. And 25 definitely goes in there, it goes in there 4 times. But the, oh, is that true? No, it goes in there 8 times. But the biggest perfect square, the biggest number from our list that divides evenly into 200 is 100. It's 100 times 2, and you must come up with the biggest number on our list that divides evenly into the original number. Now, 100 is on our list, so the square root of that is a lovely whole number. It's 10. 2 is not on our list. Its square root is a decimal, so it's going to stay behind. 10 times the square root of 2, or 10 radical 2, is a simplified version of square root of 200. Let's try one more, and then I think you've probably got this. Number 5. The square root of 256. Give it a shot. Okay, now, this one's a little tricky because you're going to find that a lot of the numbers up there divide evenly into 256. If you really truly wait till you find the biggest one, it's going to be 64. 64 times 4. But here's the thing. 64 is on the list. 4 is on the list. And when both of the numbers are on the list, it means that this one would have been on the list if I had gone out past 100 a couple more steps. So what you can do, the answer is just going to be a whole number. This is already a perfect square. So you can take the square root of 256 and you simply get the nice answer of 16. The square root of 256 is 16. You don't need to write it with a radical because it is a perfect square and it's on the list. And now ask me for the simplifying radicals assignment.